that we just learned about the definition of equivalent fractions and identifying and naming them. So just as a refresher, equivalent fractions are fractions that represent the same amount. Today's lesson, we are going to start to generate equivalent fractions, and we're going to do that with fraction representations and models. The two models that we're working with today are fraction strips and number lines. We've worked with fraction strips a lot, and fraction strips are great because they're easy to draw. They're rectangles. We can partition them pretty evenly, and they're quick, and we like to be efficient mathematicians. So this fraction strip is representing 1/5 because I have 5 parts of my whole and 1 part is shaded in. The next representation that we're going to focus on today is the number line. The number line is another amazing, efficient tool for mathematicians to use to represent fractions. You just need to make sure you always know where your whole is on your number line. It's really easy to see a hole in a fraction strip. It's usually just created one. Sometimes there's 2 next to each other. That hole is really easy to identify. With a number line, that hole could kind of be anywhere, so you really need to be on the lookout to see how it's labeled and where that hole is. You also do not want to be counting the hash marks on the number line. You want to be counting the jumps to figure out your denominator. So if this is representing 1/5, so that means that between each hash mark is a jump. 1, 2, 3, 4, 5. So this number line is partitioned into 5 pieces, and my dot is at the first piece. So we're going to be using these fraction representations to generate more equivalent fractions. So let's get into, this is problem 1A on your problem set. So we're going to do this example together, and then you can go through 1A through D after this example, and then pause this video and we will go over the number lines. So first step you always need to do when you're generating an equivalent fraction from a model is you need to identify what this fraction is representing. I don't see any fraction here. So let's identify what this is. Let's count the pieces of the whole first, and then we'll count the shaded. So 1, 2, 3, 4, 5, 6, 7, 8. 2 are shaded. So this fraction is 2/8. So my job is to try to figure out 2 other fractions that represent the same amount, making those 2 equivalent fractions. The best way to do this is to partition this number line into more pieces. So everything I do to one part of, this fraction strip into more pieces. So anything that I do to one of these pieces of the fraction, I have to do to every single one of them. Doesn't matter if they're shaded or not. All of the pieces of the whole have to get the same thing done. So what I mean is I'm going to chop this piece in half. I cannot stop there. I have to do every single one of those pieces. I'm partitioning each one of them. I'm cutting them right in half. So now, instead of having 2 pieces shaded in, let's get that one clear. I actually have 1, 2, 3, 4 pieces shaded in. And instead of having 8 pieces as my denominator, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I have 16 pieces of my denominator. That is how to create an equivalent fraction from these fraction strips. Now you can just do this again. You can cut each of these in half again. So now, instead of having 4 as my numerator, 1, 2, 3, 4, 5, 6, 7, 8. I have 8. And I have to make sure that I'm cutting each one of these. I can't stop at my numerator. And I'm going to count all the way down, and I should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. You should start to see a pattern. I'm not going to do anything with this pattern yet. I know some of you are eager, but you should start to see a pattern to help you know how to partition this. There are countless other ways you could have done this. These are 2 examples. You could have actually gone to bigger pieces. And you could have seen, actually, I can go to fourths, and only 1/4 is shaded in. So you don't always have to go to smaller pieces and bigger denominators. You could try to go to bigger pieces and larger denominators. So you're going to go through 1A through 1D, partitioning, making sure you're actually labeling what the fraction is before you get started, and you need 2 equivalent fractions. Pause this video and go through that activity, and then we will come back for the number line. All right, so hopefully you paused that video, you did all your work, and now we're ready for the number line. The number line is really similar. It's kind of can look like a fraction strip if you close it up. So these concepts are going to be the same. Like I said in the beginning of the video, the trickier part of the number line is that you never really know where the hole is. Our hole is down here, so we can label this. Remember, we're counting the jumps, not the lines. So let's find our denominator. 1, 2, 3, 4, 5, and I have 2 jumps. So this fraction is 2/5. Just like with our fraction strips, we can partition this number line. We just have to make sure between every line, every dash mark, we're doing the same thing. So I can just partition this, cutting each section in half. So now my jumps are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my dot is at 1, 2, 3, 4. I can do it again. Should start to see a pattern. 5, then 10, then I should probably have 20, and instead of 2, 4, I should probably have 8. So 2/5, 4/10, and 8/20 are all equivalent fractions, and like I said, you should start to see that pattern. We're still going to be using our models to help us answer these equivalent fraction questions. So the 2A to 2D, we're going to be using our number lines. I want to encourage you to get up and look at other students' number lines that are working on the same lesson as you, and double check them, see if they're getting different ones than you, and kind of compare with them. So you are free, once you are done solving these, to get up and collaborate with others in your lesson.